Hello, everyone. Welcome to today's webinar, Knowledge Graphs versus Vector Search, Why Your Enterprise Customers Need Explainable AI. I'm Dan Landau, and I lead marketing at AI Fund. We're so excited you're able to join us today. A little bit about AI Fund. We're a venture studio, and we work as a minor co-founder to empower entrepreneurs to build AI-based companies. We want to help them achieve success quickly. We're a team of AI pioneers, operators, entrepreneurs, and investors. This event is hosted by AI Link, the community by AI Fund, where entrepreneurs build great AI companies together. For more about the community or to join us, please go to aifund.ai/community. Thank you for joining us. If you have any questions for our speakers, please put them into the Q&A feature in your webinar controls. We will definitely be getting to questions later on. And to preempt your first question, yes, this will be recorded and we will share it afterwards to everyone who registered. I'd like to introduce our panelists today. Eli Chen is a principal technical architect at AI Fund. He helps build AI companies from the ground up. He co-founded Credo AI, which pioneered the AI governance category. Previously, he was CTO at multiple startups and held engineering roles at Netflix during its transition to streaming and Twitter through its IPO. He holds patents in streaming media and AI model assessments. Alison is CEO of Claritrace, an AI systems intelligence platform. She was previously a developer advocate at Neo4j, the leading graph database company, and she contributes to the NIST Generative AI Public Working Group on AI Risk Management Framework. She was a national finalist for the Stevie Award for Female Entrepreneurs. Eli, I'm so excited for this conversation. Please, what are you going to tell us?
Yeah, to start, we're actually in an age where we're building with a really exciting but new type of computer, and I'm going to call it the transformer-based large language model. At the core of it, it is a way. It is a new computing type that takes a fixed set of context and outputs some predictions of usually text, but now it could be multimodal. But let's kind of restrict the topic to text for now. When we first learned about this technology, we were using it for chatting. You know, a user asks a question, the transformer LLM sends a response back as role playing to be a helpful AI assistant. But over years, we've found that there's plenty of other ways that you could use this LLM technology, such as in workflows or for agentic systems. And some of these are not even question and answering or chatting interfaces. For example, document analysis is a great use case of this LLM technology. Early days of LLMs, we recognized that the limitations of the context window forced us to do clever engineering tricks to maximally use this context window. And vector database-based search of had a great term called retrieval augmented generation, was widely used. It was fast to deploy, and we saw some great results from it. But we continue to, as engineers, try to push in terms of how do we get better performance, how do we get a better recall in terms of pulling the relevant context into this window. And I think what I'd love to have a discussion with Alison about is really to talk about other ways to fill this context. Something that has been exciting, and we've actually built a few companies using this new kind of concept, is instead of doing a semantic search on a vector database, what if we treat the knowledge base of a problem, and this knowledge base could be a set of documents, it could be institutional knowledge, it could be a human-created expert sort of a wiki, or it could just be a pile of documents. What if we organize this data in a way that can make sense to not just to AI, but to humans? And how do we use this knowledge base, and how do you make it make sense? How do you construct it? So we kind of ended up in the topic of knowledge graphs. But Alison, you've been quite an expert in the space of knowledge graphs and knowledge bases. We'd love to maybe check if my description of how we are in the world LLM engineering makes sense, or do you have any insights into how do we explore usage of knowledge graphs with LLMs?
Yeah, what I really appreciate about the way you introduced it is I come from obviously the deep data science side for many, many years. And when we think about vector databases, I think sometimes it's hard for people to conceptualize what is a vector and what is a vector database and what does it actually mean. And when you take what you mentioned and we start to connect the dots, that's really where the knowledge graph comes to life. So for folks who may not be as familiar with what is the knowledge graph, Neo4j is a graph database, but the knowledge graph is the actual interconnection of what you have. So to your point, if you have maybe you have some documents and there are topics in those documents, and those you have many different documents about that topic, you want to show that those are related. Or maybe you have some structured data that's connected to that you also want to connect. And the concept really is, how can we map in a physical database form or in a physical data model form what we know to be true, either in the data or in the world, the business logic that it's reflecting.
Yeah, and by the way, knowledge graphs and expert systems is not new. Of course, I think a lot of folks have maybe memories, maybe great or poor memories of knowledge graphs, from 30 years ago. I think
Yeah.
what makes this timely today is that you don't have to have only humans create these knowledge graphs, which, as we learned 30 years ago, is not scalable. But now we
Mm.
can actually use LLMs to generate these knowledge graphs. But we're still experimenting the capabilities and limitations of using AI to generate knowledge graphs. Allison, what are some success stories or best practices, or maybe some failure modes that you've seen in terms of using LLMs to generate knowledge graphs?
Failure stories are always the more fun ones, right, Eli? I think when folks first started looking at, I think Varun Shenoy was the first person that I knew right after the LLMs came out from, I think he was at Stanford and had done the first usage that we saw of creating the graph from the LLM in the modern era. And I think one of the challenges that started out early on was ultimately what's the mechanics of what happens when the LLM creates the knowledge graph is it looks into the data that you have, and it is basic, most basic. It's looking for entities, and then it's looking for relationships between those entities. And as anyone who has done named entity recognition or entity recognition with in NLP historically, we know that what is considered an entity can be very wide, and it could have high variance from one document to another. So when we look at entity recognition in a single document, what's important in that document may not be important across the corpus. And I think some of the early, I don't know if it's really a failure, but the sort of the stepping stones were around having too many entities and too many relationships and not having it be really guided. Some of the ways that what came from there is obviously many people in the space have been working on it. LangChain, Diffbot, Neo4j. And what we came to is the next iteration was around how do we then use constraints. So I can say, I want you to look for these specific entities or these specific relationships. So if we're working with a legal client, they know that certain contracts are going to have certain structures. And so bringing that element in, that became really successful. How do we create the hierarchy of the data itself? And now, obviously, we've elevated to MCP servers to help with extracting those knowledge graphs as well. So there's many ways to attack it. But I think the biggest challenge that people have and where folks fall down the most is giving the guidance to the LLM or whichever tool you're using about what entities and relationships do I even want to get out of this data. And that's usually a really big blocker for folks early on.
Yeah, we actually had a really great success in one company build where we created a graph of relationships. This is for a industrial high stakes risk management use case based on documents of both processes and incidents, we were able to create a graph of risks and subcategories of risk, and then we could connect relationships to specific incidents, but also we could use the incidents as a way to connect to predictions of future incidents, and using the graph relationship to see, are there any missing predictions as a way to do not just root cause analysis, but prediction. But in this case, while it was successful, it caused me to wonder, we were able to be successful in this use case, in this graph construction, because we were deeply embedded into this use case and knowledge about the documents and the structures we want. So there was a lot of engineering involved to create the graph. And of course, when we talk about high quality graphs, we have our evals to make sure that there's no disconnected nodes or there's not too many hops between nodes. But I'm curious how one would do this if they were just jumping into this kind of technology, this methodology. Is it something that we have to learn from scratch? Are there some best practices? Do you have to bring a subject matter expert? What have you seen, Allison?
Yeah, I would say my general advice for folks these days is some of the traditional principles of data management, data cleaning, data modeling approach, we still want to fall on those. So my sort of the general idea is if there's something that you can do programmatically or have some structure to, I would definitely say don't ignore those elements. When it comes to building something out for the first time, what do I mean by that? If one of the instances that we had is we had a series of documents that were all XML, and there's a natural hierarchy inside that XML. And what we ended up doing is we tried it. We had actually done this with the World Bank, trying to help them solve a problem. We had looked at if we let the LLM extract the graph, if we give very clear direction to the graph, or if we do a combination of parsing and LLM together to extract from the graph. And what we found was that, especially in contracts, when it isn't exactly very explicit where an element may or may not be, the LLM is going to be really helpful. If you're in a situation where something is very structured, then the parsing actually did better to create the graph rather than letting the LLM do it. And I think the key when you're getting started is to take what I call a soft eye at your unstructured data that you're looking to map. And first ask yourself, is there any innate structure in the documents that we have? Is that something that we can leverage? And the way you leverage it is in multiple ways. In one, as I mentioned, clearly we have one of our test as elements is SEC data. SEC data, it's formulaic. Every quarter, those forms are the same. So we know section 7 is always going to be X, section 8 is always going to be X. And you can use that to create some nodes and some guidance. But it can be that the structure is not explicit. So as you mentioned, knowing what is explicit and what is implicit in the unstructured data that I'm trying to extract, and from there, choosing the right tool.
Do you have any guidance on graph construction quality? Is there a way for a team to feel like they're continuing to improve the schema of the graph, the quality of the graph? I guess what's daunting about this is that it is new for many teams out there, and there's this kind of confidence that can be given to teams that they say there's a process to keep improving it. You don't have to be perfect in the beginning, but you can keep improving it. Any guidance on evals or ways to measure the quality of your graph construction?
Well, you mentioned a couple of them. Looking at, do we have a completely disjointed graph? So from a structural perspective, do you have a fully connected graph, or do you have separate subgraphs? That's one way that you can look at it. Another thing that you can look at is you can look at the uniqueness and the variety of the relationships you have. So as I mentioned, if you give an LLM free reign to create a variety of relationships, what you may find is you have a very long tail of counts on the relationships themselves. So what we're looking for is you're ideally looking for a graph that reflects some sort of reality, right? Whether it's subject reality, business logic, and as you mentioned, doesn't have a lot of one-off relationships, one-off occurrences of an entity. So if I have an entity and it only has one relationship, is that a useful entity? The big thing to look at is you want to look at, because I work in label property graphs, is you want to look at the distribution of the label of the node type. And what that is going to show you, if you do sort of an experimentation and throw spaghetti at the wall, what you're going to find is you're going to find there are certain label types that you're going to have high counts on. And what you then want to do is if you have a label that, so let's say a label could be person, company, topic, risk factor, any of those types of entity labels. Do you have many labels that only have onesies or twosies? In that case, you're going to want to refine, because there's clearly something about that node that in that label that you have that can be useful, but maybe you need to compress, maybe you need to refine. The other option is to start with a very clear, structured way. And what I usually prefer is I'm going to start with this small use case. Be really clear, start with one use case. Graph is going to be new. Graph rag, or how you're leveraging it for context, is going to be new. Start with something really clear of one area. From there, I encourage you to stop and actually stand at your whiteboard and say, if I were to think about what this represents, what's in it? Right? I have a company, that company has these products, those products have feedback, the customer provided feedback on that product. Stand at a whiteboard, old school, pick up a pen, pick up a dry erase, and actually draw out what you know. Because what's important is going to be in your cognition. You asked another really interesting question, which is, do you need the SME on this? I would say if you are an engineer and someone has just given you a large mass of data and said, make sense of this, you may not have access to an SME. And there are ways that you can, as I said, run it open, see which labels sort of pop out, because it'll give you the organic structure that's really there. But ideally, working with an SME is always going to be more expeditious. In that case, you can say to the LLM, regardless of which method you're using, I want to find customers, I want to find tools, I want the version that their issue is with, I want whatever it is that you're looking to extract. You can be really clear that that's the knowledge graph that you want to be extracted from this data. I always say start small. Graph and data models are very forgiving. You're not tied in like in the ERD where you have to re-engineer everything. They're very forgiving, especially early on. But I would say really work with the SME, stand at the board, draw what is true, and start from there.
What do you think about my QA process? So I consider myself a bit of a cyborg, and the whiteboard is not really my default.
Sorry, my age is showing.
I like to work in the terminal or a Jupyter notebook. Something that's a little bit frustrating to me is when I'm QAing the graph and I'm taking a use case and doing this wet neural network exploration of the graph manually. I don't find there is great tools for going through a graph exploration use case. I'm running Cypher queries on my notebook, kind of doing things by hand. Do you think there is a more efficient way to explore a graph through a specific use case?
I think you're addressing two things. One is the EDA of the graph itself, right? And are you looking at it from a visual perspective or from a metric perspective? I think, within Neo4j's IDE and within the console, you can certainly have a visual exploration, but the reality is most of the time, the graph itself is going to be so big, visual exploration is not necessarily efficient. So when I think about EDA on the graph, I think of the basics such as, what are the labels that we have? What is the distribution of those labels? How many properties do we have? And looking at the schema visualization itself. Then based on that schema visualization, the very basics of the EDA. But then I like to do things like run graph analytics algorithms, run graph data science algorithms. I'll run a community detection. So community detection, especially on unstructured data, my general management approach and understanding approach for these systems is I do three things. First, I connect. So I'll run a similarity based on the vector. I'll do a vector similarity, and we'll do a k nearest neighbors, and I'll connect to say the 5 most similar based on the embedding. What I do is I'll do a clustering of those. So based on these interconnections of similarity, we'll do clustering. And then from there, I'll do community detection. So connect, cluster, curate. And that community detection allows me to go in. And now what I do is I will do EDA on the cluster. So look at what is maybe the word length? How is that cluster, how dense is that cluster? How many pieces do we have in this cluster? Because maintenance of these RAG systems and maintenance of the embeddings is the one area that I feel is a way that you can really improve the outcomes really early on because one of the things that we noted when we built our own system is we did this connect, cluster, curate, and we found that we had high densities in the vector space, right? So for example, we were using our documentation on graph data science, and we had certain elements about, I think it was it was a way that we described unidirectional versus bidirectional algorithms. And that language appeared on many, many pages. And when I think about when I'm trying to build an intelligent system, I'm always looking for the right context. And if you have high density space because you have high knowledge space, one of the biggest challenges you have is how you're how you're sampling in that area. What is the re-ranking strategy in your implementation system? And one of the things that I'm really curious about is the balance between if we have these high density spaces, I call it sort of AI gravity, the sort of black holes where we've got a lot of really dense information, how do I make sure that I still have the right sample within that same small space? So those are some of the areas that I really dive into, is in the embedding space itself, and how can we really curate and understand what's in the graph that we've built.
Oh, you do have to help me walk through your dense response for a bit, but
Sure.
maybe I should just ask some clarifying questions. First off, simply, do knowledge graphs naturally coexist with embeddings? Meaning, can knowledge graphs work independently of embeddings, or is it best practice to have embeddings along with your graph, or I guess can they work completely disjoint? I'm curious. Yeah.
Yeah, I skipped over the whole connection. So let me create that relationship between these two pieces of knowledge. In the label property graph, our approach is you have a node that represents the document. You have individual nodes that represent the chunk. So similar to a row that you may have in a vector DB, you have a node representing that chunk. That chunk has a relationship to the document. It also has a relationship to the chunk before and after. And then the text that is represented by that chunk is one of the properties on the node, and the embedding of that text is another property on the same node. Sometimes what we'll see is we have folks who have a very clear chunking strategy, but they have different systems where they want to use different embedding models. And the great thing about it is you just add another property. So I may have a GPT-5 embedding. I may have a Sonnet embedding or a Gemini embedding. Each of those embeddings is just a property on that node associated with that text. So one of the beauties of leveraging the knowledge graph is that the vector capabilities are features inside of the database structure. You don't necessarily have to have a separate vector DB. It's a feature within the knowledge graph itself.
I see. So you can do, for example, a semantic search to find you a node, and then you'll be able to use the graph to grab, neighbors of that node, all within one. I guess this is the graph database provided by Neo4j.
So we're talking about two separate things. One is the actual storage, which is the database, and then what we have on top of that is the retriever. So how are we accessing that information? And one of the libraries I use quite a bit, obviously the Neo4j GraphRag library. Within that, you'll have the vector plus graph retriever. You'll have like a straight vector retriever. Within LangChain and LangGraph, they have these same types of retrievers. And to your point, the beauty is that you have the ability to have that semantic search and bring in the context. This is where this whole conversation started today. How do we have the right context? So if I'm in customer service and I am someone, I'm the AI agent in customer service and I have a customer that comes to me, it's not just they have a problem with this product, it's they have a challenge with this product and this product is this version. What I know about this version is it was released then. We know this customer has this version and this purchasing history. So if I were a human agent in that customer service moment, I would look up the customer. I would have that visual context. And we need our agents and our AI to have that same context. So how do we do that? How do we build that? We build that by allowing us to connect that semantic search and the structured context through this one query, which we call vector plus graph.
Yeah. Maybe just to kind of challenge that a bit, what do you think are the downsides of missing that semantic search, and maybe some things like use a relational SQL query to fill your context?
I mean, you certainly can, right? If we're thinking of, and it is true, if I'm doing just a vector search, I could do it in a vector DB. I don't need a graph for that.
Right.
And if I'm doing something even that's just Cypher, the language of graph query, where it's just the structured portion of, say, this customer purchased this history, you could have that in a SQL database. That's very easy as well. Where graph comes to really sing is in the moment when you need to traverse from one to the other, when the metadata associated with the vector isn't enough, or where you're trying to expand into that structure based on something. So one of the instances that I talk about a lot is, in this SEC data, what we have is we have a lot of people in fintech that actually use this type of query, where you have some sort of unstructured element that's informative about the stock or the company or some element. You are trying to look into which companies or which stocks may be impacted by X, or which mutual fund am I concerned about based on this unstructured piece. And what that would look like is you would have the unstructured vector database. It would say this is associated with these particular stocks. These stocks are owned and are part of these various mutual funds. I want to be able to understand which mutual fund might I want to invest in based on what I know about this unstructured risk piece. And so it's when you're connecting what's clearly semantic with what's clearly structured, and you really need to tie the two together, that's where the graph does really well. Other places where the graph, and again, I just came from Graph Summit, New York. So I spent a lot of time with fintech folks recently, as well as in Amsterdam. So it's sort of at the front of mind for me right now. Being able to connect semantics with these deep structures. I talked to someone who was looking at company ownership. So you have a company that owns part of a company, and that company is invested in these other companies. And being able to traverse and understand that in this and connect it to semantics is really where they're getting a lot of value.
Well, I love seeing your excitement about what's going.
I am very excited.
I would love to hear from you some of the concerns I've heard from friends and fellow co-founders. I've heard there are challenges of using graphs and graph databases when it comes to time series data or data that is frequently changing. And specific examples I've heard was similar to what you were describing in the financial space. Maybe there are I don't actually know the specific use cases, prices changing many times rapidly. Do you
Mm.
think there are any problems to be solved relating to data changing frequently instead of a set knowledge base?
Yeah, I definitely think, and as you know, you're an architect. Any architect who is thoughtful is going to recognize that the full architecture of your solution is never going to be one thing, right? You may have you're going to have different tools for different pieces. And I will say for traditional high, if you're looking at a traditional time series, having a time series DB or having something that's more structured can be the right way to go. And by connecting that with your graph database for what really is truly graph and where you need graph, it's that combination, just like the semantic with graph is where it really sings and separately they do things well. It's a matter of what belongs in the right place for the right use case. I will say the querying of the graph has gotten significantly better. Sadir Hasby, the head of product at Neo4j, just released Infinigraph, which is just millions and millions of nodes just working really, really smoothly. I think one of the challenges, honestly, has to do, there's the structural aspect and the fact that maybe a time series might work well if you need a particular use case and the graph isn't as helpful. Not everything is a graph, of course. But the other thing too is just the talent and knowing that you have people that understand it. We do have, like, everybody's got their vibe coding and we've got our Claudes and we've got our all the different tools that we have from a vibe coding perspective. And we know that those tools serve us best when we have a subject matter expert and you have, and not even just subject matter, but you have a structural expert. So I think the biggest challenge in graph right now, from what I'm seeing, is really having the talent in house to be able to leverage the graph wisely. I mean, I had a conversation with a not to be named startup company that does a lot of work that seems to be graph, but it's actually not built on graph. And when I asked them about it at the AI conference, I asked them about it and they're like, well, we wanted to, but we didn't have anybody who knew how to build it. So we just did it this way. And so we hacked around it this other way. So that's one of the other things that I think is really interesting is, you know, how do we get our AI engineers to expand into this space and really know when is the right moment for graph. We were chit chatting the other day, and I said to you, I said, if you're a startup and you're in AI and you're not using a graph in some form, you're innately building in technical debt, and it's definitely true because when we think about our AI systems or our agentic system, I mean, you know, you're from Credo, like, you know, like it is naturally a network, right? The behaviors of the agents, the behaviors of the tools and the software and how it's working is innately graph. And so to be able to even understand our systems, we need that graph. So to your point, not everything is a graph. Graph isn't the right answer for everything, but it's a matter of the right tool and the right database in the right portion of your architecture.
I love that. And I would say that's actually probably the primary role of an architect, which is to use the right tool for the right job. And some failure patterns I've seen is to do something because it's quick and easy, or because it's just other people say they're using it, so you kind of copy their pattern. It applies to when you're fine-tuning a model versus, you know, prompt engineering. It goes both ways, right? Like sometimes you're doing something because it's easy for too long, or you're not doing something uh, even that goes against the grain, but it could be much simpler. So
Mm.
I think that is a good kind of description of graph thinking, which is it's another tool in the toolbox. And if you want to do semantic search, you have vectors, you have embeddings, great for semantic search. But if you have relationships, if you want to traverse, we didn't talk about all the other benefits of having a graph, like explainability and human-to-loop review. But
Yeah.
I'm looking at the time, I know we have questions. I do not want to skip the other huge part, which we didn't yet cover, which is traversal of the graphs. So maybe we could spend a few minutes on this topic. You know, myself personally have done very structured queries of graphs, meaning fixed cipher queries. Um, we have experimented with using LLMs to generate Cypher queries on the fly. It seems powerful, dynamic, yet we have also seen LLMs write improper Cypher. So it's, of course, that introduces other failure modes. And there's also other aspects of if you could imagine having an agentic AI traverse your graph without any limits. I'm not sure, if any companies actually have adopted that approach. But what have you seen, Allison, in terms of different ways of traversing the graph?
Yeah, I mean, obviously, we have many folks that we've worked with who were using, as you said, these structured cipher queries for things like, fraud detection or, what I call them the non-obvious communities and pieces like that. When it comes to the LLM and the traversal, you bring up a couple of really good points. One is in general, what are we trusting the LLM to do when it comes to querying our databases of any kind? The other element is why I like to, when we're building out something agentic, being really specific, especially with the Cypher in the tool calls. If we know that we have certain traversals that are going to come up often, you can put that into the tool ahead of time. You can have it be relatively dynamic by passing the specific schema. So you always want to pass the schema as it exists if you're having something generate. But I highly encourage folks to, like I said, if it's something you're going to be using often and you can be explicit about it, be explicit. The nature of the semantic plus graph is such that it runs the vector search and then you add in the Cypher query on top of it. So you can create that package tool. And that's mostly what we're seeing. We do have folks who are experimenting with doing the text to cipher on the fly. And again, within range, mostly we're seeing if it's high risk, high impact, then you really want to be explicit with it. And you can fine tune for Cypher, but if you're in mission critical systems, I wouldn't suggest giving the agent free reign of any kind, whether it's a SQL database or a vector database, but I'm risk averse.
Great. I guess maybe we should Allison, what do you think? Should we take a pause and answer some questions?
I think we should definitely answer some questions. I saw some really interesting ones passing by. So I think we definitely should. A consultant would be helpful. It seems so fundamental a piece of architecture that I wonder if this is a do not try without caution. We've been doing semantic search for a long time in RAG evals, so we have what feels like a solid foundation of knowing our documents and quality. Yeah, I mean, many people have their RAG implementations set already, and so you have those values. But what I would say in that moment is ask yourselves, look where your RAG implementation where are you finding that it's not as complete or not as whole? Where are you seeing that you want the most improvement? And then to take a look and say, is there something that I could add into this context that would give me a better output? And how do I then connect semantically to whatever that structure, from that semantics to that structure? And I would think that's a really good place to start expanding from RAG into a potential graph RAG utilization.
Sometimes I would suggest going back to the drawing board and just kind of asking, are you really asking for a semantic search? And
Yes.
sometimes I call it a fuzzy search with ranking. Or are you looking to pull, like, for example, in a workflow where you're analyzing some context and you want to generate output, not a chatbot scenario, but a workflow,
Mm,
the fuzzy search is actually not what's intended, but I've seen many cases of fuzzy search used unnecessarily, maybe because it's quick to bring up, it's quick to embed and put into a vector DB, or
mhm.
there's many patterns and frameworks in place that you could just put it together really fast versus like this concern that it will take months to bring up a graph database. But the failure modes I've seen are fuzzy searching and chunking, introducing hallucinations because LLMs are actually not great at saying when it doesn't know things. So when you have artificial boundaries introduced by hallucinations and the LLM not knowing there is structure in place, like not knowing that the chunk means something, like, or like, for example, I like to use the example that if you're in a high stakes scenario, you join a new company,
Mhm.
want to know what are the HR policies so you make sure you don't violate them. You probably
Yeah,
want to traverse a graph to make sure that you've gone to seen all the policies and hit
yeah,
the end and know what the limits of the policies are versus to do a like a wiki search. Like, does
yeah.
what I do here violate the policy? I don't think that's a confidence inspiring as actually traversing through a graph.
Yeah, and you bring up a really good point. It's sort of where Microsoft, their graph rag element came in. They were looking at doing sort of summaries at the hierarchical levels across. And to your point, the semantic search is only going to ever give you what's close to what you asked, but the completeness really is about that traversal. So did we start at the beginning and get to the end, or in a legal structure where if I have a chunk and it refers to another portion of the contract, then I'm going to want that portion of the contract to be brought in. If it says as noted in amendment 2B, that reference needs to exist between that chunk and the next chunk, and that's where the art really comes in. And to your point, what goes back to what I said from the very beginning: if there's something structured that you can do and something programmatic that you can do from the beginning, do it. When you're processing those documents, it's not necessarily about the chunk, but what is the structure that's in it that it's connected to? And by building it that way and building that vector access that way, it makes it very, very easy for you to do exactly what you're talking about, whether it's explainability, but really understand the bounds of context for any given problem solver workflow.
Would you agree that the structure is information? And
Yes.
yeah, okay.
Sorry. I'm very excited. Yes, I mean, that's one of the beauties of graph 2 is that the physical structure of the connections tells you so much about what's actually in the system. So highly connected areas know that you have a lot of density in that moment, or if something's really spread out. One of the things you mentioned earlier was the number of complete hops from, like, what is the largest length of hops from one node to another? What's the maximum length? What that number is really is going to depend on your use case. If we have folks where they have a graph of their entire business. So they'll have supply chain and customer information and IT information and HR. In those systems, it's many, many hops across the system, but that's intentional. So it's really a matter of what is the structure and what does the structure tell me about what I've actually encoded.
Yeah, especially in high stakes scenarios. I think there's not as a strong need for a low latency single hop query, and
Right.
there's much more value to allow this traversal through a graph through multiple hops.
Yeah, I mean, if it's a single hop, it's probably something you could do in SQL most of the time, right? Or if it's a single hop from a chunk to some metadata, it's something you could do in a vector database. But the graph really sings in many to many. It sings in multi-hop. It sings in AI systems where we have this hop across types of context. So I completely agree with you on all of that.
All right, let's see if we could tackle another question. Um,
Let's see, we've got some here. There's so many good questions.
Well, Allison, I'll let you.
I always start at the most recent. So one of these questions is there's two questions here that are actually really good. So what are some of the key questions to ask non-technical stakeholders to help you learn about the nature of the questions they're asking to drive your design of the graph or embedding structure? Again, it's typical, and Eli, you can tell me what your methodology is, but it's really a traditional discovery. Anytime you're building a tool for someone, you're going to go through the same process of understanding I always start with what are the actions that are going to be taken based on the system that we're building, so that we know what that final outcome is. And then just general sort of system discovery analysis. I don't think it necessarily changes for graph, but what you want to listen for from an architectural perspective is different. You want to be listening for things that are a sequence. You want to be listening for things that are, many to many scenarios. You're listening for, is there a pathway involved? Those are the kinds of things that when I hear them, I say, oh, this might be a good moment to bring the graph in. How about you? When you think about design, like asking your non-technical stakeholders and to answer your architectural questions, what's your methodology?
Yeah, I go through the job to be done kind of path. And sometimes I notice that the graph schema is constructed without the job to be done mindset, and then we miss certain features. For example, generalizability of you want to, let's say you wanted to take a specific incident back into the risk incident kind of risk management use case. You want to go to a specific incident, generalize into a broader maybe category, and then use generalization to do predictions. You can only do that if you're constructing their schema in a certain way that you are I guess focusing on this generalizing job to be done, rather than like another job to be done is categorizing all the details. So I guess one takeaway is it's not automatic. Maybe that's something that could be a path to work on, is to make graphs construction automatic. But at least for now, we still have work to do as architects and designers of the system, which is to focus on the customer, focus on the value, focus on the job to be done, and design a schema so that it does the job, rather than to kind of just focus on the technology in the schema and just make sure that I have a beautiful graph, but forgetting that there's a customer to serve.
Yeah, jobs to be done is always my favorite approach. So I love that you dropped that. That's always a great way to do it. But yes, it really is. Ultimately, it's always about what is the outcome, how is the tool being used, and how do we architect for that success, for sure. Do we have some other questions here? Let's see. How you structure observability and triggers that might drive schema evolution in knowledge graphs versus embedding models. Concepts like versioning and backwards compatibility come into play. One of the ways that James's question, how can you comment on how you structure observability and triggers that drive schema evolution? Observability, I think we can never talk about observability enough. Right. And I think especially as we're building out these systems, there's so much that we can learn when we start looking at that systemic level. What is the trigger for schema evolution? I think that is going to come depends on the use case, clearly, but most of the time people make errors in their schema development one of two ways. They make it overly simple so that you don't have enough hops that it's useful, or they make it so complex that, to your point, you can't generalize. And so what I would say is, if you're finding that what you're getting is not detailed or complex or useful enough, then you might want to take a look at the schema. I would say it's always good to have a regular cadence of evaluation. I mean, clearly you've seen lots of cases where you have a schema and then you realize, oh, we're not getting the output we need. Let's go back and we need this sort of nuance or that sort of nuance. In graph, it can come up when you have inefficient queries. So if your queries are really slow running, oftentimes it could be that the schema needs to be reworked because you're diving into a property or you're getting what we call a super node. Everything's traveling through this one hot property. So those are some of the ways that we know it's time to reevaluate the schema. But what are sort of the triggers for you, Eli, that you say, oh, maybe it's time for us to re-examine this architecture?
I don't have a great answer for that, but I enjoyed listening to your
Okay. All right. Let me see. What some other questions that we may have.
I guess
Um,
maybe I'll
yeah.
comment on the question about two concrete examples of right tool for the right job.
Mm,
Um, an interesting story that I've kind of adjacent in the agentic coding space is that the inventor of Claude Code, Boris, has said that he purposely, or the team purposely decided not to use RAG and embeddings of the code base and use agentic search. And of course, this is not a graph, but on the file structure and the directory structure of your code. And
mm,
they saw much higher precision, higher output from the code generation of that specific tool. And I'm using that maybe as a story to say that, it might be wrong, it might be right, but the choice of a tool there, which is agentic search versus vector DB, saw material and I believe significant effects because I use Claude Code for coding and not IDE with a vector DB mapped for your code base.
mm.
Um, but there's so many examples of right tool for the right job. Allison, do you have an example?
Yeah, I was working with someone recently and they are doing a lot of work with graph analytics. And what they ended up doing is they were projecting into the graph certain telemetry to then actually they wrote the elements back into BigQuery specifically because they were looking at the time series on some of the graph analytics. And so the reason they did that was they wanted to run the algorithms in one moment, but they wanted to be able to track them and take a traditional time series ML approach to the changing of the graph over time. And so that I thought was a really good combination of high availability and yet computational appropriateness. And I thought that was a really nice marriage too. So that's just one of the examples that I saw that I thought was really thoughtful and clever.
Yeah, the old kind of ML kind of lesson that you don't always need the largest, most complicated neural network to do simple tasks. I think that still applies to this day.
Yeah, for sure. I don't know what
Okay.
other questions we may still have. I know we're coming close to time.
I would recommend a question for you, Allison. Uh, from your experience, the question is, most enterprises struggle to move graph proofs of concepts to production because of scale, governance, and integration challenges. How have you seen these challenges being overcome? I know that in our previous chat, you're talking about the nascency of this technology and where we're going.
Yeah, one of the things that, and again, in our pre-conversation, we talked about the fact that the graph database and think Neo4j is what, 12, 13, 14 years old at this point, hasn't been around nearly as long as some of the other structural aspects. And right now, because so many people are focused on AI and graphs are really coming into their moment as a required tool, we're definitely seeing a lot of development and a lot of push in the productionizing of or sort of the maturity of the hardware associated with the graph database. So as I mentioned, there's a lot that's really, I mean, started with sharding, and now we've got InfiniGraph, and things move from there. But to your point, governance, and you do have role-based access. You can set the access based on different types of relationships and different types of nodes. So there's lots and lots of capabilities to actually manage that. So I think one of the things that happen is it's very common when we go to conferences and we'll talk to somebody and they'll say, oh, I tried Neo4j once like 7 years ago. Oh, I tried it when I was doing my PhD. Oh, I remember that, and it was really clunky. It's like saying, I use GPT-2 and LLMs are bad, right? Like everything has changed so drastically. So I would say there's been a lot of like exponential improvement in the hardware associated with how the graphs run. Role-based access, there's lots of different ways that you can bring in governance. And so I would say that for what we're seeing now, the jump from POC to production is significantly expeditious than it was even, 3 years ago, life before Sadir came along, right? We definitely have seen a lot of expeditious or exponential improvements over the last couple of years. So if you tried graph databases in the past, come back, give us another try. We've improved.
We have an interesting use case that actually was great for the governance concern, which is we would create separate graph databases for one used to create data private to a customer, another graph that is more on public knowledge, so it's more shared and can be benefited from all the customers. Is that well? There's benefits to saying these are physically different databases, and you can even say different geolocations. But is that the best way, or maybe are there simpler ways to deal with these sort of governance concerns?
Yeah, I mean, people do it in a variety of ways. We've seen solutions where even in, say, a RAG system, there's the general knowledge, but they'll also within your login, you'll have your own piece, and then the vector index will be built across your personal data and the public data, so that you can traverse across those and you can query across. So that's one way people have done it. As you mentioned, there are folks will use a virtual dedicated cloud and have subgraphs within it, depending on, and a lot of it really has to do with the risk tolerance of the customer and what their boundaries are. Because in some cases, like especially in government spaces, they say, we don't mind having duplications as long as we have a really clear line. And so that's where it becomes a risk reward scenario. And I mean, the risk tolerance is part of the architectural decision as well. So it's there's lots of different ways that you can approach it.
Well, I'm looking at the time, and Dan's here, and I think we nailed the timing.
This was great. Thank you so much, Eli and Allison. You guys made this so fascinating, and I really appreciate everything you shared here today. For everyone in the audience, thank you for joining us. If you're an executive in transition or a serial entrepreneur or ready to build your AI startup with AI Fund, please apply to join us at AI Link, the Community by AI Fund where entrepreneurs build great AI communities together. That's aifund.ai/community. We'll be sending this recording off to everyone who was here and who registered. We have a great slate of upcoming events for the community, including other conversations like this and networking happy hours in the Bay Area. So hope to see you all again soon. See you in the community. Thanks, Eli. Thanks, Allison.
Thanks for having us.
Thank you.